Now we're ready to find how to use the tan ratio to determine the side length of a right triangle. So remember our tangent ratio, the tan of an angle, so tangent of theta. Never leave your tan hanging. You always have to follow it with its angle value. The tan of the angle is equal to the side opposite divided by the side adjacent to it. And when I'm talking about sides, I'm talking about their lengths. So if we look at this very first diagram, the 90 degrees is here, which then tells us this is the hypotenuse. We don't really care about the hypotenuse for this particular question. What we want to find is the side that's opposite to the 70 degrees. So in this case, our x side is the opposite, and then that leaves us with the side here being the adjacent. So if I think of my tan ratio equation here, the tan of the 70 degree angle would be equivalent to the x over the 3. Now to get x by itself, it's being divided by 3, so we can undo that by multiplying both sides by 3. So multiply both sides by 3, and then we're going to use our calculator and the special button on our calculator to do this. So you want to find that tan button, and before we actually play with that, you want to check your screen, your display screen on your calculator, and you should see a D in the display screen or a DEG. If you don't see that, if you happen to see an RAD or an R or a GRAD or a G, we need to change your mode. And you might have a button that says mode. You might have to search on the internet how to switch to degree mode for your calculator. It should be fairly straightforward to find that on the internet if you Google that. Some of you will have a DRG button that will just allow you to toggle between those 3 different modes. For me, my older calculator, I have a mode button, and then right below the screen I see that if I push 5, it will change me to radians, 6 will change me to gradients, but number 4 is my magical degrees. So I hit mode and then 4, and that switches me to degree mode. But mine by default is in degree mode all of the time until I switch it to something else. All right, so my calculator, I put my angle in first, and then I hit my tan button, and then I times by 3. Some of your calculators, you don't need to do it in that order. You're going to hit tan and then the 70 degrees, get that answer, and times by 3. Some of you can do 3 times and then do the tan of 70 degrees. In any case, your answer should be 8.2 to 1 decimal place. 8.2, and that unit would be centimeters for that side length. Okay, looking at this next example now, you see the right angle, the side across from that is going to be called the hypotenuse. That doesn't matter for this type of question. What we want to focus on are the other 2 sides, the opposite and the adjacent. Now we're given this angle, so this is our angle of reference. The side across from that is the opposite side. It's opposite to that 35 degree angle. That means x is our adjacent side. It's next to the 35 degree angle. So we're going to start with the tan of our angle, which is 35 degrees. That ratio should equal opposite, which is 12, divided by adjacent, which is x. Now, I can't multiply both sides by 12. Well, I could, but then I would have 144 over x. I still have a fraction there. I still don't have x by itself. So here's what we're going to do. We're going to multiply both sides by the x to get it away from the bottom, to get it from being the divide part. So we're going to have on the left side x times the tan of 35 degrees, and that's equal to 12. So from here, to get x by itself, it's being multiplied by the tan of 35 degrees. So to undo that, we're going to divide both sides by the tan of 35 degrees. So then what we're left with is x is equal to, now again, my calculator, I'm going to do this in one step. I'm going to hit my 12 first, 12 divided by, and then for me, I need to do 35 tan. For you, depending on your calculator, you'll do tan 35 or 35 tan. It doesn't, you just have to learn how that works. So let me try that. Divided by, all right, 35, and I hit tan, and then equals, and I get 17.1 approximately here as my answer. 17.1, and that's centimeters again. And these are approximated answers. I've rounded them. So hopefully you're able to get that. If you're having trouble finding out how your calculator works with this, please send me a message and I'll try and help you through it. All right, so that's how you can find your side lengths. We can also use the tan ratio to find an angle in a right triangle. So this only works with right angled triangles. You cannot use it with other ones. So I've just taken a screenshot of the picture on the first part of this handout. We're going to solve for angle C to the nearest degree. So angle C is our angle of reference. That gives this as our opposite, which we knew was 1, and our adjacent, let's see if I can close that up, that's opposite, and our adjacent is the 3 centimeters. So the tangent of angle C will equal 1 over 3. Now, that's what the ratio is, but we want the actual angle value. What we need to do is get rid of the tan that is surrounding the C, that is the operation on angle C. To do that, you'll notice above your tan button on your calculator, you have a tan with a -1 beside it or above it. That is the inverse operation of tan. It's the opposite. It's like the undoing of the tan. So we're going to do inverse function of tan on the 1/3. So you probably will need to insert some brackets in here. For me, I'm going to do the 1 divided by 3 and get that answer first. And then I'm going to go shift tan, or you might have a second function button, tan. That gives me angle C is equal to approximately 18 degrees if I go to the nearest degree. 18.4 to 1 decimal place, but 18 degrees to the nearest degree. And if I wanted to find angle G, then I could do 180, subtract the 90 degrees, subtract the 18 degrees, and that would give me angle G. All right, determine the measure of all angles to the nearest degree. So we have a couple triangles here. Now, it doesn't matter which one I start with. I could either start with angle A or angle B. I already know angle C is 90 degrees. That's a no-brainer because it's marked. Let's say I'm going to make angle A be the one I want to solve for first. Doesn't matter, you could choose B if you want, but just make sure whichever one you choose to be your angle of reference, the side across from it will be opposite. The side next to it is your adjacent. And of course, the hypotenuse is always the hypotenuse, regardless of which angle you're talking about. So now I can go tan of angle A is equal to 4.2 divided by 7.9, because it's opposite over adjacent. So my angle A will be the inverse function of tan on that answer of 4.2 divided by 7.9. So on my calculator, 4.2 divided by 7.9, that gives me about 0.53, and then I'm going to go shift tan, and that gives me about 28 degrees here. Angle A is approximately 28 degrees. And now to get angle B, I can do 180, subtract the 90, subtract the 28, and that will give me angle B. Now, some of you might have decided that you wanted to solve for angle B first. If you do that, as I said before, if you choose angle B as your angle of reference, that switches things. That makes this side now the opposite to angle B, and this side is the adjacent to angle B. It switches the role of opposite and adjacent. So if you started with tan of angle B and did opposite over adjacent, you would have had 7.9 over 4.2. And your angle B then is the inverse function of tan on this answer. So you're going to do that calculation, and it should give you that angle B is 62 degrees, I believe, but let's try that on the calculator just to make sure. I was just doing the 180 minus the three things in my head. So 7.9 divided by 4.2, that gives me 1.88 roughly. Shift tan gives me 62 degrees approximately. Okay, or you could also from here have done 180 minus the 90 minus the 28 to get angle B, which is 62 degrees. Okay, so both will work. All right, now I don't know, I put a theta in here. I think I was trying to decide whether I just wanted you to solve one or solve another, and I forgot to actually cross that out or take that out on my version here. If I want angle D as my first angle, this is opposite, this is hypotenuse, and this is adjacent. This trig stuff is going to fall apart for you if you cannot identify which side is opposite, hypotenuse, and adjacent. So the tan of angle D will equal 5.8 over 12.2, which means D will be the inverse function of tan on 5.8 divided by 12.2. So angle D, that's a D, is approximately 9.8 divided by 12.2, second function tan. That gives me approximately 25 degrees. And then we can get that angle F. Angle F would be equal to 180 degrees minus the 90 degrees minus the 25 degrees. And since these are all right angle triangles, you could even just do 90, subtract the 25. And that will give you 65 degrees as angle F. You could also have used the trig to get angle F, which would be switching the role of adjacent and opposite. So hopefully this is making sense so far, because the next lesson is going to go through two other trig ratios called the sine ratio and the cosine ratio. So enjoy your tan. Good luck.